fluid dynamics. Consider it covered. Any questions? Yes, we're on.
Can you go over, the second to last question on the textbook problems?
What is the second to last problem on the textbook?
It's, it says two identical pucks collide on an air hockey table, one puck was originally at rest. And then it says the question is, if the incoming puck has a speed of 6 meters per second, and scatters to an angle of 30 degrees, what is the velocity, magnitude, and direction of the second puck?
Okay, so. Thank you.
I'm sorry.
Identical pucks. We don't state that it's an elastic, perfectly elastic collision until the end. But we do that.
Wait, it's a perfectly inelastic collision?
They're perfectly elastic.
Oh,
If it were perfectly inelastic, then it would continue in a straight line. It would not be a two-dimensional problem. All right, collision. What should pop into your head when you think physics problem collision? Yes.
Momentum's conserved.
Now, I don't know what the masses of these are. It says in the problem that they're identical, so it could be whatever mass you want. I'm just gonna make it for this ease of it all. I'm gonna make the mass 1 kilogram. Or you could just use M. So what is the total initial momentum of the system?
6 meters per second.
So close.
Momentum. You said momentum.
Yes.
6 Newton seconds.
Yeah, or meters per second if you wanted to add to that times kilograms, or kilogram meters per second. So we have, we can actually go one step further.
In what specifically?
Momentum is a vector.
Yes, it is.
So you want the direction?
Yes.
Positive.
We can do better than that because I defined a coordinate system.
To the right.
Somebody just said it? I hat, yes. All right, so I have 6 I hat. That's gotta be equal to the total momentum afterwards. Now, there is a special case here that if the masses are the same and the initial speed of one of them is 0 meters per second, in other words, one's at rest, if it collides and it's a two-dimensional collision, that they will careen off each other at a right angle. So that was the whole bit about if that's going off at 30 degrees, this has to be going off at 60 degrees. So we have 6 I hat coming in, that has to be the total afterwards. And it's a two-dimensional problem, so it'll be composed of, I'm just gonna call this V1 final, which I will label as A, and V2 final, which I'll label as B. So it becomes A cosine 30 degrees. You know what, I'm just gonna make all of these I hats so I don't have to write it each time. 3 cosine 30 degrees plus B cosine 60 degrees.
So 1 kilogram is, well, the first ball is B.
This is 1 and 2.
So then what's A and B?
Those are the velocities final.
Oh.
And then my j hat, what is my initial momentum in the j hat direction?
0.
Yes. And that's gonna be equal to a sine of 30 degrees minus b sine of 60 degrees. We have 2 equations, 2 unknowns. It's a math problem. Well, I know cosine of 60 degrees is 1/2, and the sine of 30 degrees is 1/2. Cosine of 30 degrees is radical 3 over 2, and that's radical 3 over 2. So I have 6 is equal to the square root of 3 times a over 2. Let me stick the a up front just in case. Plus 1/2 b. And I know that a over 2 equals b radical 3 over 2. So I can easily solve for a in terms of b, plug into the first equation. 6 is equal to b radical 3 times radical 3 over 2 plus b over 2. B equals 3 meters per second. Plus, of course, there's a Carol's arrow or something.
How did you get rid of like? Oh, so you found what A is for the J hat one and
Yes.
substituted it in the I hat one?
Yes.
And then figured out B, and then after figuring out B, you figure out A?
If you want, what was, the question was, what was the final velocities or?
It said, what is the velocity of the second puck?
Okay,
Is the second puck the one that was at rest?
I'm considering that the second puck.
Okay, cause that part confused me.
So I guess V2 final would be 3 meters per second, negative 60 degrees. Since it asked for the final velocity, you do need to actually give it in either polar or rectangular form.
And then the second question, like the B part of it says confirm the collision is elastic.
Perfectly elastic in the language I typically use. So what does perfectly elastic mean?
It means the change of kinetic energy is equal to 0.
Okay, so we just have to figure out what is the kinetic energy beforehand and what it is afterwards. So K initial, 1/2 times 1 times 6 squared, which is 18 joules. K final, well, I've got 2 pucks there, so I got 1/2 times 1 times, oh, I guess I do need to figure out A. A would be 3 radical 3. So that is 3 radical 3 squared. Plus 1/2 times 1 times 3 squared. That's 4.5. 9 times 3 is 27, divided by 2, 13.5. There we get the same thing. Now, if I were solving this with a calculator, I probably would actually work out what radical 3 is as opposed to just leaving it in that form.
Isn't that imperfect?
Yeah.
Inaccurate, technically?
Say it again?
Radical 3.
Right? You mean irrational?
Yes.
Yeah, radical 3 is irrational, but
So would it not be inaccurate? 2. write it out.
Depends on how many decimal points I took it out to. Yes, it would be inaccurate to do it that way.
Okay.
It would be close enough.
How close is close enough? How many decimal points?
Well, take it out a couple decimal places and you're fine.
So until what shows up on the calculator, basically? Like so?
I would probably take it 4 decimal places.
So not 9.
I would not.
Okay.
I've had students do that though.
What about until you can't round it? Like blah 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 4 can't be rounded out.
That's fine.
Okay.
Just don't round it off at the 10th place.
Okay, and then my second question was, there's a part to a question, like I understand everything before that and I can get to that answer, but I don't know why I'm getting a different answer for like the angle that we have to find. It says a puncher drops a ball from rest vertically 1 meter down onto his foot. The ball leaves the foot with a speed of 18 meters per second at an angle 55 degrees above the horizontal. What is the impulse delivered by the foot? Magnitude and direction. I found the velocity that I was looking for. I got 21.8 meters per second, just like you, but I'm not getting the same angle and I don't know how to find it.
Alright. As usual, I tried to look for my book in my office and couldn't find it, so I apologize for that. Oh, what are the chances I have a printout so I don't have to keep borrowing from you? Forces. Fundamentals. That is the wrong textbook, I believe.
What question is that you're asking?
Second to
Question
last.
22,
22 on chapter 9.
chapter 8.
Yeah, I've got the printout from the previous textbook. Oh, wait. Nope, that's still previous textbook. Okay. Okay, which rock, you said 22?
Yeah.
A punter drops a ball from rest vertically 1 meter down onto his foot. The ball leaves the foot at a speed of 18 meters per second, an angle of 55 degrees above the horizontal. What's the impulse delivered by the foot? So they specified magnitude and direction, but they didn't have to. Impulse is a vector, it's automatic. So impulse, I think you use J. I can't remember what I used before, if I used J or I.
I use J, but because there's joules, I get confused.
Or I flip back and forth depending upon my mood in the semester and the position of the moon. Impulse is the change in
Mood?
momentum, or it's the force times time.
Did you say mood or moon?
Position of the moon, or
Okay.
my mood. So we know that it is dropped 1 meter, and then afterwards it goes shooting off at an angle of something that's now darkened. What was the?
It was, I don't have my phone. Okay, here. It says the speed after it leaves the foot is 18 meters per second at an angle of 55 degrees.
55 degrees? Alright. So we just need to figure out what is the momentum before and what is the momentum afterwards. Did they give us the mass of the ball?
No.
And ask what is the impulse?
Yeah.
Okay. So we could make up a mass, or our final answer will have M in it.
No, I think it was, well, what it showed and what I did was, I think you're supposed to use like a cake formula before, and like using that cake formula, you find the initial velocity, and
Oh,
then,
yeah.
but, oh yeah, I never figured out mass.
But impulse is the change in momentum. There's gotta be a mass in there
Yeah.
somewhere. So we'll just have either M in our final solution, or we will have we'll make up a number. So it's gonna drop 1 meter from rest. So we can use the cake formula, we can use conservation of energy, we have choices here. If we're using cake, I know the initial is 0 meters per second. Acceleration, I'm assuming it takes place on Earth. Let's make down positive, 9.8 meters per second squared. The displacement, 1 meter. And that's all we really need. We're just trying to figure out final velocity. Or final speed, actually, VI squared. No, we need final velocity plus 2a delta s. So that's gonna be equal to 0 plus 2 times 9.8 times 1. So VF is the square root of 19.6, which is about 4.5.
Or 4.41.
Okay. So, since we are gonna be looking at change in momentum after and before, we do need the same sort of coordinate system. We have the speed just before it's kicked. However we wanna set this up, that plus going down was just to figure out how fast it's going at this point. I'm now going for the entire problem set up. The more traditional, I had J hat like that. And so my impulse is going to be the change in momentum, which is the final momentum, minus the initial momentum, which is 18 m, and that's for mass. At 55 degrees, minus 4.43 times the mass at negative 90 degrees. And so now it's just a math problem. I presented this in polar form. To put it in rectangular form, well, we just do some sines and cosines.
Yeah, so for like the x value of the final velocity, it would be 18 cosine 55 degrees, and then the y one would be 18 sine 55 degrees. So it's 10.3 meters per second and 14.74 meters per second. And then after that, we're supposed to find the change of velocity, right?
Yeah.
Okay, and then the formula we have to use is like change of velocity equals square root of change of x value squared plus change of y final velocity value squared. Why? Why do I do that?
All right, so 8 is 18 and 4.43. 18. Let's just look. Impulse is the change of momentum.
Right.
Assume that the mass of the ball is not changing.
Yes.
So this would become mass times the change in velocity, since mass is constant. So this is mass times final velocity minus initial velocity, which is mass times 1855 degrees. And that's in meters per second, minus 4.43, negative 90 degrees. Which is mass times So if I pick the standard coordinate system, I hat, J hat, then that becomes 18 cosine of 55 degrees, I hat, plus 18 sine of 55 degrees, J hat, minus, we can go through the exercise of 4.43 cosine of negative 90 degrees, I hat, plus 4.43 sine of negative 90 degrees, J hat.
Dr. Fox,
But
I cannot read those
That's
words at the
zero.
top of the screen.
since mass is constant,
Oh, okay.
and so this is negative 4.43 J hat. Sine of negative 90 degrees being negative 1. I'm subtracting it, so it ends up being the mass times my I hat component is just that, which I believe is what Laurent said. And then the J hat component is 18 times the sine of 55 degrees plus 4.43. Now, I heard you say this part, and then you said some other things that didn't all click.
So, okay, when you figure out the x and y value of the final velocity, after that, we're supposed to find the change of velocity.
Right.
And I think I was just confused on like how we found that, cause it was the change of velocity x squared plus change of velocity y squared. And then you square root all of that, if that makes sense.
Were they putting it in polar form in the end?
It's cause they're using the Pythagorean